Hello everybody, in this lesson I will discuss linear patterns. Different types of number patterns exist. Here we will focus on something we call the linear number pattern. In the sequence 2, 4, 6, 8, we see that by adding 2 the next term can be found. We can make the conjecture that if any term Tn is known, then Tn plus 1 is equal to Tn plus 2. A conjecture is a statement made by noticing a pattern in the hope that it is true in all cases. Given the sequence 8, 11, 14, when we say 11 minus 8 is 3, and when we say 14 minus 11 is 3, we can conclude that there is a constant difference of 3. To get to the next term, we will add the 3. This is what makes this a linear number sequence. T4 is equal to 14 plus 3 is 17, and that is how you will get to the next term. Term 5 will be the previous term, 17, and you add plus 3, the constant difference, and then term 5 is 20. Term 6 will be 20, the previous term, plus 3, the constant difference, is 23. Then for the general term, this is how we will go about finding it. Term 1's value is 8, and 8 consists of 3 times 1 plus 5, and the 1 is the n, the number of the term. Term 2 is 11, which is 3 times 2 plus 5. Term 3 is 14, 3 times 3 plus 5. Term 4 was 17, 3 times 4 plus 5. Can you see the pattern? Therefore, Tn will be 3 times n plus 5, and then the formula for the general term of a linear sequence is Tn is equal to d, can you see the constant difference, times n plus c. And then for this sequence, the general term is Tn is equal to 3n plus 5. Consider the sequence 8, 11, 14. We say the sequence is linear because a constant number was added. D, that is the symbol for the constant difference. The formula to find D is equal to term 2 minus term 1, or D is term 3 minus term 2. The formula for the general term of a linear sequence is Tn equals Dn plus C. You must remember that formula. Now let's look at some examples on linear sequences. Now here I give you a little sequence with smiley faces. In the first term there's 1 smiley face. The second term there's 4. The third term there's 7. Now what's the question? Give the next 3 terms of the sequence of smiley faces. So first of all, let's find D, the constant difference. D is term 2 minus term 1, which is 4 minus 1, and it's 3. But then let's confirm that this is indeed a linear sequence. So we will find D again, but this time round we will say D is term 3 minus term 2. 7 minus 4, which is 3. And the fact that the constant difference is the same Therefore, we can say that this sequence is linear. Now, for a linear sequence, how do we get to the next term? We add the constant difference, which in this case is 3. Therefore, the next term, 7 plus 3 is 10. And then the next one, plus 3 is 13. And the next term, plus 3 is 16. B. Give a formula for the general term of the sequence. So we start by writing down the formula that I just discussed in the previous slide, which was Tn is equal to Dn plus C. And then we calculated D, the constant difference, which was 3. So we substitute. Now our next problem is we have to find a value for C. And what we do is we zoom in on the first term. Now the first term, n is equal to 1, and then T1 or Tn is also equal to 1. Tn means the value of the term. In this case, it's 1. So now we substitute in Tn's place 1 and in n's place 1, and we're going to solve C. Therefore, it becomes 1 minus 3 is C, and negative 2 is C's value. Then conclude the general formula for this sequence is Tn is equal to 3n minus 2. Now number C says, how many smiley faces will there be in the 100th term? And now this is where we won't add 333 until we get to term number 100. That will take forever. We will use the formula for the general term of the sequence. Therefore, we worked it out. Tn is equal to 3n minus 2. Now, in n's place, we substitute 100, and then that means the 100th term's value is 298. Let's look at another example where we will use the linear pattern formula. So look at the following arrangement of tiles, and I counted them for you. In the first one there's 8, the second term is 12, and the third term is 16. The question, how many tiles will be in the fourth arrangement? Now first of all, let's work out the constant difference D. D is term 2 minus term 1, 12 minus 8, which is 4. But we have to work out D again to confirm that this is indeed a linear sequence. This time around, we will say D is term 3 minus term 2, which is 16 minus 12, which is 4. Therefore, there is a constant difference of 4. The sequence is linear. Now to get to the next term, we will add 4. So 16 plus 4 is 20. So the fourth arrangement will have 20 terms. B. Give a formula for the tiles needed for the nth arrangement. So I'm actually asking for a formula for the general term. We start with Tn is equal to Dn plus C, and then we calculated D's value, the constant difference, was 4, and we substitute in D's place 4. Again, to find C's value, we zoom in on the first term. Now that means n is equal to 1, the first term, and Tn is 8. How many tiles is in that arrangement? Then in Tn's place we substitute 8, and in n's place we substitute 1. And then 8 is equal to 4 plus C, and we solve C by saying 8 minus 4 is C, and 4 is C's value. Therefore, the general formula for this sequence will be Tn is equal to 4n plus 4. C. How many tiles will be in the 50th arrangement? You agree? It will be silly to add 4, add 4, add 4. We don't do that. We use the formula that we just calculated. Tn is equal to 4n plus 4, and in n's place we substitute 50, and then the answer is the 50th term's value will be 204. In the next video, we will do some practice examples on number patterns. Click on the video in the left-hand corner to take you straight to the next lesson.